Hello everyone, welcome back for a new video. So today I want to talk about generics in TypeScript and I want to start with React. So why React? Because it's the tool I use every day together with TypeScript, and I think it's a nice idea to expand on the last video I made about types last week. So let's have a look at what we can do with generics in React. So let's say we want to make a component that renders something like a list of items. All right. So we have two ways. We can either have a component that essentially is going to take a specific shape of an object, or we can make it generic. Of course, here we're going to see how to make it generic. So let's imagine we have an app, const app, which is our React application, which is going to return a list object, a list component. And what this list component is going to take as props is going to take items that we want to render, which of course is going to be an array of elements, for example, made by ID, name. And then the second parameter that we want to have is a renderer, which essentially is going to take the item that is being passed through, and then we can define how to render such item. So we're going to take item.id and item.name. So in a normal scenario, what we are going to do is that item is going to have a particular shape given by ID of type string and name of type string as well. However, let's have a look at how we can construct this component so that we don't have to make it as such. So what we can do, let's make our component, our list component. So const list is gonna take props and it's going to return something. But for our purposes, doesn't really matter what it's going to return. We're not actually going to visualize anything in this example. Now the props are gonna have a certain shape, which is list props, like you will do in any React application. List props, and what do we have in this list props? We're gonna have items, which is an array of objects, and we have a renderer, which takes an item of type any for now, and returns a React node. So now, how you can see here, items. Okay, items, we can also assign it to any, but that is not the purpose of the exercise. The purpose of the exercise is to see how to use generics so that whatever we pass in here can actually be inferred inside the item. How do we achieve this? Well, we can achieve this by specifying a generic here. So we're going to say that this one is of type item, and then this list props takes this parameter of type item, which we pass here, of a generic type t. Items is of type t, and item is also of type t. So now what happens is that this type so now what is going to happen is that this list props takes this generic type t, which is passed through this list item, which is going to be taken by the item that is passed to the item section, and this one they're all of the same type, but this one is the constructed. Now what is complaining about? What's happening is that there were a white space here, so wasn't really liking it, but of course this is just a sample code and doesn't matter. So what can we do now with this? If we're gonna duplicate, and let's add a React fragment in here. So let's have a look. So we have a new list item, and now instead of name, this is gonna have first name. Now here is inferred that this property is gonna be first name. So depending on the shape of the object passed on the items array, the renderer is gonna infer what is the shape of this item object. Now to do a brief recap, the way this one works is that we have a generic type item, By the way, you can prefix it with t item. Depending on the company you work for, you might have different conventions. But the concept is you have your generic here that is passed, and is passed through, this one is the interface of our list component, which takes two props, items and renderer, which of course are not generics. These are the props we expect the component to have. Then we pass on it a generic type of type item, and this type item is an array of items here, for items, as well as the type of the single item. So this way, TypeScript can infer what is the shape of the object used. Now, let's have a look at other types of generics. I want to talk for a second about the keyword operator. And what is the key of operator? The key of operator is an operator that allows to produce literal unions of the keys of an object. So, for example, let's say we have a type names, actually interface names. Gonna have first name string, family name of type string, name string, title string. What we can do, if we want to have a type of names, key of names is equal to key of names. And now what it means is that each one of those is a key, is one of those keys. So if we have a const first name, and this one is type of key of names, can only have the value of either family name, first name, name or title, which they are coming directly from the keys of this object. We have seen how to use the key of object. We can have a look at how to get a value from an object, like a deep value from an object. Okay, so let's imagine we want to write, we have a object, and this object has some values in it. So for example, foo, and now we have a value bar, fits. Now this one has a second nested object, for example, deploy, step 1, string, step 2. These are values. Now we want to write a function that basically, given the object, we can specify which keys to take, for example, foo and bar, and it's going to return us such a value. So writing such function is fairly simple. So what we can do is const extract value, we take the object a and b, and we return the object of a and b. Now, of course, this is untyped, this is completely untyped, and on top of that, everything is basically of type any. Okay, so how can we get the value of such object to work and also type check, so that value is not of type any, but can actually infer that, for example, in this case, what I'm gonna do foo and bar is gonna be of type string. Change this one, let's make this one true. This one is gonna be 12, so that is a number, and this one, let's keep it as a string. So how can we do this? We can do this by using generics. So here, we're gonna add a generic. And the first parameter we wanna use is the T object type. So this one is the type of the object passed through. So this one is T obj. So it means that the type of this object is of T obj, which is going to be inferred depending on the value that is being passed through. And here we can see that if you hover the function, you can see that this is the shape of the object. Now we need to get the value of the first key of our object. So what we saw just earlier is how to extract with the key of operator from a type the keys of an object. So what we can get the first level type, and it's gonna be of type extends. So it belongs to, essentially, to the key of T obj. And this, it's not a great name, let's call it T first. T first is gonna be the type of this variable A. So now what we know that T first needs to be a key of T obj. So needs to be given this object. T first can either be foo or deploy because it's the key of such object. So if we extract type of obj, X can either be foo or deploy. This is what essentially is happening here. We are saying that T first is a key of T obj. Here I have to do type of bj because here it's an object. So I want to know the type, the keys of the type of this object, which is foo and deploy. Now the same thing, something very similar, happens for the second key. So let's call it T second. T second now extends the key of T first. It doesn't extend the T first, but actually extend the key of, because this is second level, of the original type of T obj, and then we access with one of the keys T first, and this is what is going to be given to T second. So the second line is essentially equivalent of saying, give me the keys of T object, but then give me the objects of, because T first can only be of type foo or deploy, I can access only foo or deploy. So it's going to read only the sub-values of either foo or either deploy. So can either be bar or fizz, or can be step 1 or step 12. So now, when I access this object with foo and bar, value can only be a string. But if I change this, TypeScript is going to infer correctly that it's going to be, can only be fizz. This one can only be either deploy or foo, and now this one is failing, so I need to do step 1 or step 2, and value is now of type number.